So, hello everyone. Thanks for coming to my talk. Today, I'm going to be talking about Horde, specifically how it can be used by small teams, and I'll show you ways we've reduced cost, and I'll show you what's actually involved in deploying Horde. So before I get into things, just a little bit about me and the company I work for. So my name's Ash. I'm a lead real-time developer at S1T2. While my main focus is leading development on our Unreal-based experiences, I'm also responsible for maintaining and developing the DevOps pipelines for these projects. So at S1T2, we mostly create immersive and interactive experiences, typically for institutions like art galleries and museums. And we use a lot of different technologies, but we mainly use Unreal Engine for these experiences. So at S1T2, we're a team that cares about fast iteration. That's kind of due to the experimental nature of our work, as well as short timelines and the need to adapt to changing requirements. Our core team is also small, but we may expand our team with contractors or other partners depending on the work we take on. And our team is also hybrid. You know, some people work from the office or work from home, or maybe on site in another country. So having remote access to our tools and infrastructure is important. Actually, the picture in the bottom right is from the time we did a job in Dubai, and I got stuck there for like 5 months. So this talk is targeted towards small teams who are interested in Horde, but are unsure if it's the right thing for them, as well as teams that don't have continuous integration set up yet. To get the most out of this talk, it would be best to have some knowledge of Horde or similar tools, but it's okay if you don't. Actually, how many people went to Jack's talk earlier on Horde? Oh, not many. So Horde is Epic's custom continuous integration platform. It may even be a bit reductive to call it just a continuous integration platform. But what sets it apart is its native support for Unreal tools, projects, and workflows. It offers build graph support natively and integrates with other Epic tools like Unreal GameSync. And it was also designed with scale in mind. You know, it's got to accommodate the needs of a team the size of Epic. So why would you choose Horde over something else? Horde's out-of-box experience is kind of unrivaled, specifically for Unreal Engine projects, just because of the native integrations and streamlined process. It's also kind of an all-in-one solution. It comes with most things you need out of the box, which reduces the need to create glue between different tools or services. And by choosing Horde, you're kind of buying into the Unreal ecosystem of tools and the Epic way of doing things, which kind of reduces the friction involved to introduce more Epic tools into your workflow or pipeline. And obviously scale. If you're a global scale team, Horde does make a lot of sense just because of its ability to accommodate teams of that size. So why wouldn't you choose Horde then? Horde is pretty opinionated in its workflows and integrations. So if you disagree with these or they don't work for you, then it might not be the right choice. And one of those integrations is Perforce. While you could find some way to integrate it or migrate to Perforce, you might find that it's more effort than it's worth. Or maybe you're a studio that does a mix of Unreal and non-Unreal projects. Horde's going to make less sense for things that aren't Unreal. Or perhaps you already have a system that works. It can be hard to justify moving away from something that's already getting the job done. So I've broken up this talk into 2 main sections. First, I'm going to give an overview of Horde's requirements, kind of show you what the minimum is, and then we'll build a high-level plan for our infrastructure. And then in the next section, I'm going to walk through this plan, building it up piece by piece, going into more detail, and show you ways that we have reduced cost. So let's start with Horde's requirements and start building that plan. So in Horde's documentation, there's this section that gives an overview of Epic's Horde deployment. It's got an Amazon load balancer, 2 Linux containers serving the dashboard, 12 Horde servers in total, DocumentDB, Elasticache, several hundred EC2 instances running the Horde agent, and on top of that, 100 machines on premises. Here we can start to see the kind of scale that Horde is designed for, but as a small team, we obviously don't need all of that. So the bare minimum Horde deployment will look something like this. We'll have 1 Horde server paired with Mongo and Redis databases or something that's compatible. as well as something to serve the dashboard. We will need somewhere to store things like build artifacts and logs. This can just be the local file system of our Horde server, but it can also be a cloud-based storage solution. And we will need at least one agent so we can actually run jobs. And then, of course, our Perforce server, which will contain our project, our engine, and Horde configuration. There's also a few external services that we can run alongside Horde to kind of extend its features. The first is an authentication provider. This will bring things like login flow and user management. We will also want somewhere to send notifications to. Out of the box, Horde integrates with Slack for notifications. And Horde also has an issue system which can integrate with Jira, but I won't be talking about that today. So now we have an understanding of what we need to deploy. Where should we deploy it? Should we put everything in the cloud or on premises or something in between? So going through our options, an on-premise deployment can be cheaper in the long term. We're able to purchase hardware upfront rather than paying ongoing fees for cloud hosting. But it can be harder to scale. It's not like we can just spin up more servers at the click of the button. And it may also be less stable than a cloud deployment. We're more susceptible to things like power or internet outages, as well as hardware failure. So a cloud deployment can be more expensive in the long term, but it's going to offer greater flexibility and the ability to scale on demand. And it may also offer more stability. Large outages are uncommon, and when we're in the cloud, hardware failure isn't really a concern anymore. And then hybrid can allow us to tap into some of the benefits of both, as well as giving us the flexibility to pivot. So going with hybrid, it's not really going to be the cheapest option, but can kind of give us the best of both worlds. By putting our critical infrastructure in the cloud, we can be more confident in its stability. And by putting our agents on premises, we can save some money by buying hardware up front or repurposing hardware that we already own, rather than paying ongoing fees for high-spec cloud servers. All right, so now we have an idea of what we need to deploy and where. Let's start building that plan. So first, we're going to put that critical infrastructure in the cloud. This will be things like our storage, our databases, and our servers. Any outages here will be the most disruptive, so we're going to put all of it in the cloud. And then our agents will be on premises. This will help save us a little bit of money. And I'm also going to throw in a Perforce proxy and Unreal Game Sync, but I'll talk a bit more about why they're here later. And then finally, we have those third-party services for authentication and notifications. So now we have a high-level plan for our deployment. I'm going to go into more detail for each component as we build it up piece by piece. So I'll be covering things like deploying our server on the cloud in AWS, configuring Unreal Game Sync and Perforce, setting up an authentication provider, and then sending notifications to Discord. So let's start with the Horde server, as it's kind of the centerpiece for this deployment. Just as a reminder, these are the 4 things we need to deploy for our Horde server. And that would be the Horde server itself, MongoDB and Redis databases, and something to serve the dashboard. As a starting point, we can reference Epic's Horde deployment again, and we can consider these managed databases offered by AWS, which are DocumentDB and Elasticache. So these managed databases are kind of intended to be drop-in replacements for Mongo and Redis. They come with extra features out of the box, like high availability and automatic backups, and they sort of offer a more streamlined experience. But here we are trading features and convenience for an increased cost. So instead of using DocumentDB and Elasticache, we could also deploy Mongo and Redis directly to self-managed EC2 instances. But you're going to have to put more work in if you want those extra things like automatic scaling or backups. But this infrastructure kind of still leaves you open for scaling in the future, even if it's something you do manually. But we can take this a bit further, actually. Here we have our cheapest option. We can provision a single EC2 instance and then run all the services we need using Docker. While this option is cheap, we're only paying for one server now. It's going to offer the least flexibility. If you want to scale this in the future, you're going to have to migrate everything to new servers. So we have a few options here, kind of going from most scalable and most expensive to least scalable and least expensive. But here we're going to choose the EC2 and Docker option. We can save some money by only provisioning one server. And although we lose out on the ability to scale horizontally, it's not something that we necessarily need to meet the needs of a small team. So we're also going to need something to serve the dashboard. It's just a static site, so that gives us quite a few options. We could use almost any off-the-shelf server. And AWS also offers solutions for this. But we can also just use the Horde server. And while we could offload this work to something else, it's going to make very little impact and also increase the complexity of our deployment. The only real benefit to hosting it separately would be that we can deploy new updates to our dashboard without having to deploy a whole new image to our Horde server. So now we have our Horde server running, as well as the required databases and the dashboard. We've chosen a low-cost solution by opting for a single EC2 instance, while still understanding the drawbacks of this choice, like the lack of scalability and the flexibility to add that in the future. So now we have a Horde server, we need to choose a storage backend for it. Horde is going to generate a few different files that we will need to store. This can be things like build artifacts, like your package builds, or logs from the jobs we're running. And Horde supports multiple storage backends for this. It can be an external cloud-based solution like Amazon's S3 or Azure's Blob Store, but we also have the option for using the local storage of our EC2 instance, which in this case will be an EBS volume we've allocated to it. So should we use that EBS volume? With EBS, we kind of have to allocate a certain amount of storage. If we run out, we have to allocate more or remove data. It can offer better I/O performance compared to S3, but that's kind of assuming there's no other bottlenecks. And it's generally going to be more expensive per gigabyte compared to S3. So what about S3 then? A nice benefit is that it doesn't really have a storage limit. You just pay for what you use. But a major benefit here is actually that now Horde can use pre-signed URLs, which essentially means clients can upload and download data directly to and from S3, kind of bypassing our Horde server. And that's going to allow us to have a much slimmer Horde server. So here we're going to choose S3. It's nice that it is cheaper and doesn't have a storage limit. But yeah, the pre-signed URLs is really a major benefit here. So now we've chosen S3 as our storage backend. It's offered lower prices and increased convenience, as well as the ability to now use pre-signed URLs. So to actually make use of our Horde server, we're going to need some agents. In this section, I'm just going to give a bit of general advice for choosing hardware, and I'll show you some configuration we can tweak to know we're getting the most out of our build agents. So in terms of hardware, some things are kind of obvious. We want a CPU with a lot of cores. With more cores, we can do more in parallel. And we also want fast storage. Our agent's going to be reading and writing a lot of files. So an SSD is definitely recommended to prevent that from becoming a bottleneck. A GPU is kind of optional. It really depends on if you plan on running automated tests on these agents and the kinds of tests you're running. And then we're going to need enough RAM to feed all of our cores. But how would you know how much RAM is enough? If you've ever compiled an Unreal Engine project before, you've probably seen a message like this. Here it's saying it's limited to one process per logical core. In this case, it's 20. And then it's requesting 1.5 gigabytes of memory per process. And there's only currently 25 gigabytes available. So it's being limited to 16 processes out of the maximum of 20. What this means is the agent doesn't have enough available RAM to saturate all of the cores. So it's not really going to be enough to just like throw more cores at your agent. I would generally recommend budgeting about 2 gigabytes of RAM per thread, which will give plenty of buffer. But what you really want is that 1.5 gigabytes per thread plus a bit of buffer. This limiter is artificial and it can be turned off. It might help in situations where the agent doesn't have enough RAM, but it's generally better just to make sure they have enough in the first place. We do disable this limiter on our build agents, just in case there's like a spike in memory usage, and we want to make sure they're always using the maximum amount of parallel actions. There's also this all cause boolean. It's kind of set true for some build graph tasks when they run on a Horde agent, but not all of them. So we want to set this to true. So now we have some Horde agents. Maybe we've repurposed some old workstations, but we've made sure they have enough RAM and we've tweaked their configuration, so we know we're getting the most out of them. So before we can actually run CI jobs, we're going to need to set up our Perforce server. Horde has two main requirements for CI. The first is that we must have Unreal Engine source code on Perforce. So even if you don't plan on modifying it, we're going to need to put some thought into how we structure our Perforce streams to ingest the engine source code. And the second is that our projects must be considered native, which is essentially a folder structure that we must follow. So starting with streams, we want to create at least two streams. The first being an entry point. This will just contain like the stock Unreal Engine with no modifications. And then we'll create another stream where we can actually develop changes in. But I would also recommend creating a third stream as a buffer between the two. And this will give us a place to merge incoming changes with our own modifications. So that might look something like this. Here we have UE engine entry, which is our entry point. Then at the bottom, UE engine main is where we're developing changes. And then in between that, we have our buffer stream for merging. The way we set up our streams, it kind of follows a similar structure. Here, UE main is our entry point. And then below that, UE dev mostly acts as a buffer, but we do develop some changes there. And then we branch off UE dev to create a stream for each project. We also have these release streams. They're kind of snapshots of the engine as we've ingested them, and they're mostly there for compiling plugins against. The next thing we need is for our projects to be considered native. And we have to meet one of two criteria. The first is that our project folder must be relative to the engine directory. And the second is if it's in a subdirectory, that subdirectory needs to be listed by uproject.rs file. To achieve this, we could just push our project into the same stream as our engine. And that's definitely a valid way of doing it. But I'd like to show you an alternative. And that's using stream components. What this allows us to do is essentially create a separate stream for our project. And then we can map the contents of that stream to any workspace created for our engine. So if you sync your engine stream, you'll also get your project in a subdirectory. So why would you even bother doing it this way? Using stream components kind of decouples your engine and project streams, meaning they can be mix and matched or merged and branched in isolation. Another nice benefit is that it can be applied retroactively or even undone without having to push files around different streams. So it kind of offers greater flexibility overall. So now our Perforce server is ready to be used with Horde. We've set up streams for the engine and we've mapped our projects to those streams using stream components. But there's actually one improvement we can make to the setup. And that's introducing a Perforce proxy. So a Perforce proxy essentially acts as a cache between clients and a Perforce server, meaning if the proxy already has a file the client is requesting, we don't need to download that file from the server. And this can lead to improvements in sync times, as well as reducing the load on our Perforce server. So what we want to achieve is something like this, where we have our agents talking to the Perforce proxy, but our Horde server is talking directly to our Perforce server. So to achieve this, we'll need a host name that resolves to different IPs on each machine. So on our agents, this host name will resolve to the IP of our Perforce proxy, and then on our Horde server, this host name will resolve to the IP of our Perforce server. For our agents, we can achieve this by adding an entry to the host file. The name on the right here will resolve to the IP on the left, just for this machine. And then on our server, we can do something similar by adding an entry to the extra host field in our Docker Compose file. And now when we configure Perforce for our Horde deployment, we can use that host name, and that's going to be used by both our agent and our server. And then finally, we'll need to actually run our Perforce proxy, and it's pretty straightforward. We just need to run the P4P executable with a few arguments. The first is the IP and port to bind to. The second is the IP and port of the Perforce server. And then finally, we have a directory for the cache files. So now we've added a Perforce proxy to our deployment. It's improved the sync times on our agents, and it's also reduced the load on our Perforce server. So now our Perforce server is ready. Let's talk about Unreal Game Sync. So I'm just going to quickly cover what Unreal Game Sync is and why you would want to use it. And then I'll show you a quick overview of how we can use it with Horde. So Unreal Game Sync is a desktop tool. Its main purpose is to streamline the steps involved for syncing the engine and projects from Perforce. And it comes with additional features like a sync filter and the ability to download precompiled binaries from Perforce or Horde. And it's kind of designed and intended to be used in that native folder structure we talked about before. So if you want to use Unreal Game Sync, you have to be using the native folder structure. So why would you want to use Unreal Game Sync? We can sync and build our project just fine without it, right? Unreal Game Sync kind of automates all the steps involved for syncing. So in one click, we can sync, build, and run our project, which kind of helps mitigate any human error in those steps. You can also kind of think of Unreal Game Sync as a launcher or a dashboard. It's at a glance, you can kind of see project health or change lists and launch other tools like Unreal Insights or Zen. And of course, precompiled binaries. We're able to sync and run our project without even needing to install Visual Studio. So now we have an understanding of what Unreal Game Sync is and why we would use it. Let's talk about deploying it. So beyond having a Perforce server, there are 3 additional things we can deploy to expand the features of Unreal Game Sync. The first is a metadata server. This will kind of provide Unreal Game Sync with additional information that won't come from Perforce, things like comments and labels generated by our build system. The next is a place to download the UGS client. This will kind of give your users a place to download it, but it'll also allow the self-updater to see if there's a new version available and then patch the client locally. And then finally, we'll need a place to download those precompiled binaries. So the old way this used to be done was by using a dedicated metadata server and then storing our binaries on Perforce. So we'd have to create 2 additional streams on our Perforce server, one for our Unreal Game Sync binaries and one for our precompiled editor binaries. And then finally, we have our build system, which will talk to the metadata server over its HTTP API. And that's kind of glue you would have to do yourself manually. But now instead, we can use Horde for all of this. Horde here is now our metadata server, and it's also storing those binaries. So we have one less service to deploy, and we don't have to create any additional streams on our Perforce server. Here, we can kind of start to see that deeper Unreal integration starting to pay off. So it's fairly straightforward to achieve this. We just need to configure Unreal Game Sync and then upload artifacts from our build graph script. So configuring Unreal Game Sync is pretty easy. We just need to add this entry to our INI and we're done. Uploading PCBs is pretty straightforward too. So in our build graph script, we have a node that is producing the binaries that we want to upload. And then we can add this artifact element that's looking for those binaries. Then if we assign the correct type and keys, Unreal Game Sync will automatically be able to find these and download them. So now we've introduced Unreal Game Sync into our workflow without the need to host any additional services or add more streams to our Perforce server. And it's also allowed our developers to sync in a more convenient way. So our Horde deployment is looking pretty good. We actually have everything we need to run CR jobs. But there are a few more services we can run alongside Horde to kind of enhance this deployment. And the first of those is authentication. So in this section, I'm going to talk a little bit about what OIDC providers are. And then I'll cover an example of integrating one with Horde. So OIDC stands for OpenID Connect. It's kind of a standard that provides 2 main purposes. The first is login flow. So that will allow users to log into your service, potentially with accounts that you created on other platforms like Google or GitHub. And then the second is user identity. Once logged in, your service will receive information about the user, like their name or their email address. So Horde has two main login flows that we need to understand. The first is signing into the dashboard. So if you browse to your Horde server, it's basically going to immediately redirect you to your provider's login page. There you would fill out your details and sign in, and you'll be redirected back to the Horde dashboard in a signed in state. And the second login flow is with desktop tools like Unreal GameSync. So when Unreal GameSync wants to authenticate, it first hosts a local HTTP server with a web page, and then it will open your browser to your provider's login page. There you will log in as normal, and this time you'll be redirected to that locally hosted web page. Unreal GameSync will see that it's been redirected to, and then store the information it received in a file to be used later. The second thing we're going to get from our provider is user identity. So when a user signs into Horde, it's going to receive a list of claims that describe a user. Claims are just key pair values. They can be things like their email address, their name, profile picture. And in Horde, we're also able to assign permissions to these claims. So if a user's email claim is ash@s1t2.com, then they can have the execute Horde permission, for example. So there are quite a few providers to choose from, and a lot of them cost money. You might have to try a few to find one that meets your needs. Horde does have a built-in provider, and it's definitely a great option if you're not planning on exposing your Horde server to the internet. It's also a lot easier to set up, and it's free. But the provider I'd like to talk about today is Auth0. Its free tier is very permissive. We can have like 25,000 users before we have to start paying, which is definitely plenty. It has all the features we need at S1T2, but a killer feature for us is that it integrates with Google Workspace, meaning we can sign in with our existing Google S1T2 Workspace accounts, and that's quite convenient. So I want to run through a quick example of setting up Auth0 with Horde, kind of just step by step, showing you the configuration in the Horde side and what you need to do in Auth0. So in our server configuration file, there's these 6 fields we need to fill out to set up authentication, which are the auth method, the OIDC authority and audience, client ID and secret, and then our server URL. So starting with the auth method, we have 4 options. Anonymous, which means no authentication. Okta, if we're specifically using that provider. OpenID Connect for any other provider. And then Horde, which is the built-in provider. Here we're going to pick OpenID Connect. Next, we'll need an OIDC authority. When you create an account in Auth0, the first thing it asks you to do is create a tenant. And this URL it generates will be what we use for our authority. So we can just copy paste that into our config. Now we need an audience. And to get that, we need to create an API in Auth0. Here, it's going to ask for an identifier. It can actually be whatever you want, but it's common for it to be formatted like a URL. It doesn't have to be a real or working domain. And this identifier is what we will use for our audience. Now, to get our client ID and secret, we need to create an app in Auth0. Here, we're going to choose single page web application. And then we also want to set these allowed callback URLs. These are essentially the URLs we're being redirected to in the 2 login flows I mentioned at the start. So we'll need this to make sure those actually work. Then in our app settings, we'll find the client ID and secret that we need, which we'll just copy paste into our config. And then finally, we just need to set this server URL. If it's unset, it will kind of default to whatever the name of the machine or container it's running on. So we're going to set that to the domain of our Horde server. So there's actually a few more things we need to change in Auth0. That's limiting access and setting a default audience. So for limiting access, there's 2 things we need to change. The first is disabling this Google social connection. It's enabled by default, and when it's enabled, it means anyone with a Google account can log into our Horde server, which, yeah, we definitely don't want that. And then we also want to disable signups on this username and password authentication. And that's going to prevent anyone from creating a login for themselves. which also don't want that. And then finally, there's this default audience setting, which is quite important. After setting up an auth provider, you might find that logging into the dashboard works okay, but logging into desktop tools like Unreal Sync doesn't quite work right. That's because Auth0 is expecting an audience parameter in one of its payloads, but Unreal Sync isn't actually providing it. So we can set a default audience, and Auth0 will essentially inject that parameter for us automatically. So we need this to make sure that we can actually log in with Unreal Sync. So now we've added a third-party authentication service to our deployment. It's given us enhanced security, user management, and login flow. And we've gained all of this with no additional cost. So now we can log in, we can run CR jobs, but we want to have somewhere where we can receive notifications about our jobs. So Horde has a notification system. It can report events to an external service, so you don't have to go check the dashboard manually. And out of the box, Horde integrates with Slack for notifications. To get the most out of Slack, you kind of have to pay for it, or maybe you're using some other platform like Microsoft Teams or Discord. So you wouldn't really want to migrate to Slack or use Slack on top of what you're already using just to get notifications from Horde. Luckily, Horde has quite a few interfaces we can inherit from, one of which is this notification sync interface. This is going to provide us with all the hooks we need to send notifications to another service like Discord. Horde also supports plugins, which is nice. It means we can extend its functionality without necessarily having to modify it directly. We just need to create a DLL that Horde is able to load. So we have a few options for sending a message to Discord. The first is using a Discord bot. It will give us access to more advanced features like the ability to create channels, but it will be more involved to set up. We also could use a webhook. This essentially exposes an endpoint for us that we can send messages to. But today I'm just going to talk about webhooks. It's kind of a more agnostic example. So you could do the same thing with another service. It's also a lot simpler. We just need to send a JSON payload to a HTTP endpoint. So to add support for Discord notifications, we'll need to create a Horde plugin, and then we can create and register our custom notification sync, and then we can send a HTTP request to our webhook endpoint. And you'll have to do all of this in a additional project in your Horde solution. So first we can create our plugin class. This is what the Horde plugin system is looking for when it loads our DLL. You can kind of think of it as the entry point for our plugin. Next, we'll need to create a class that inherits from the notification sync interface. This will expose a few different functions for us, but the main one we're interested in is this job notify complete function. Then the webhook endpoint is expecting a JSON payload that matches a particular schema. So what we can do is create some classes that match this schema, and then later we'll be able to serialize these classes into a JSON string. So now inside our job notify complete function, we can start building the message to send. First, we're going to read this notification channel from our config, from our stream config. We're essentially hijacking this config variable to store the URL for our webhook. Then we can prepare the message we want to send. We can set the title, the color, and the description using those classes we created earlier. And then we can start building our post request to send. First, we're going to serialize our message to JSON, and then we can create a HTTP post request with that JSON payload attached. And then finally, we can send the HTTP request. Now, back in our Horde plugin, we can register a singleton of this class for our notification sync. So Horde exposes quite a few APIs for us to pull additional information about the job. It's going to be things like the change list descriptions, generate artifacts, or whether or not the... It's okay. We're back. And whether or not the job failed or succeeded. Discord also has like a markdown style syntax for styling. So that allows us to customize the message further. So you can definitely take this a lot further than what I've shown today. So now we've added a way to receive notifications without having to pay for that service. And we've also learned how we can extend Horde's functionality without really needing to modify directly. So now our deployment is complete. We've opted for free third-party services like Auth0 and Discord. We've also deployed our server in the cloud while still keeping costs low. And we're also able to integrate additional tools like Unreal Game Sync without really much effort at all. So despite the learning curve, I feel the time and effort involved to getting a pipeline up and running with Horde is much lower than generic solutions. And that's because of the native integrations and the more streamlined workflow, as well as the fact that it's reduced the need to create glue between different tools. Horde is designed for scale, but it obviously doesn't have to. We can deploy it at a low cost while still meeting the needs of a small team. And for these reasons, I think Horde is actually a great option for teams of basically any size. And that's it. Thanks for listening. I think we have time for some questions.
Thanks for the talk. So did I get it right that if you download a 5.6 version of Horde, that you can use that to do CI/CD for earlier versions of Unreal, or do you have to have a Horde server per engine version?
It would be best to use the same version. The main compatibility thing is build graph. Horde will be working for a specific version of build graph. But I found I'm using the 5.6 version at the moment, and it works for 5.5 and 5.4. 5.3 has more issues because the artifact element doesn't exist in build graph, but it's quite easy to backport that.
Thank you.
Yeah.
Questions? I'm also not keeping an eye on the time, Ash. So
That's okay.
Thanks, Ash. Two quick questions.
Yes.
Number one, did you look at ECS instead of EC2 instances? Was that just like a cost thing to not go with like a managed container service?
Yeah, pretty much. We probably would have used ECS if we were deploying on multiple EC2 instances, but in this case, we just have the one, so we can just run Docker on that.
And do you have like a WAF sitting in front of those as well? Or are they just open for the Perforce server and the EC2 instances? And you purely rely on the auth to be able to like protect them?
Yeah. We just have the port open for that. Yeah.
questions?
Thank you. What's the specification for your EC2 instance?
It's a 2-core, 2 gigabyte instance.
Okay.
But I probably wouldn't recommend doing that. The only reason we were able to do that is because I made a small modification to Horde. There's a commit object that's essentially storing all the files that changed in a commit. And if the last commit in a stream happened to be like you pushing the engine, that's like hundreds and thousands of files. And it was using gigabytes of memory. So yeah, I would probably recommend maybe at least 4 gigabytes of RAM and a bit of swap. But Epic servers, I think, are 16 gigabytes according to the documentation. Yeah.
Yeah, so I have a question regarding extending hordes with plugins, like you mentioned. I'm interested in that. What would you say would be the best entry point to learning more about this, and whether like does Horde just have documentation for it as well?
I think the documentation goes as far as saying there is a plugin system, but that's about it. But I would recommend, like, most of the features in Horde are already built out as plugins. I think there's about 6 or 7 already there. So you can reference those and see what's involved.
Cool, thank you.
That's okay.
Cheers for the talk. Is there any requirement for the cloud-based services to sit behind VPS?
Sorry, I'm not familiar with VPS. Like
the virtual private system, do they have to sit on like any kind of localization, or can it just be public on the internet?
They can just be public, yeah.
Oh, awesome. Cheers.
Yeah.
I was just wondering if you'd done any studies into the sort of network bandwidths involved when you're going from on-site to off-site, and then with multiple agents and the recombination of what you're trying to build. Did you encounter any network issues?
No, we didn't have any issues. Again, using the pre-signed URLs means even the agents can upload and download data directly to and from S3, rather than that being like piped through our Horde server. And I think that's the main limitation for like bandwidth, because like artifact files can be like many gigabytes in size, right?
Yeah, sorry, not technically working, just with
Right.
build speeds. Like, so if you've got like,
Oh, okay.
it's like building much faster locally than it is over the cloud, for example.
Right. It works fine locally. One issue is hydrating workspaces. If you're running a job across multiple agents and it needs to move files across to another agent, it's going to pipe those through Horde. So it's going to upload everything to S3, and then it's going to download it back down on the other agent. And that can be quite slow. So for us, we don't really use that because of that reason. Yeah.
So thank you. Two quick question. Can the proxy can be replaced by commit or edge server?
Yep. The main reason we're using a proxy is to run it on the local network alongside the agents. But yeah, you can do that too.
And the second one, can we like is there any CI/CD that's if we work with local Zen? So when the cache has been built in other workstation, then it can be deployed or copied to another workstation using Horde.
Yeah, you can use shared Zen server for your agents. I definitely recommend doing that.
Okay.
Yeah, it's a significant improvement to the cook times for us.
Thanks.
Yeah.
Yep. I think we're
One question, can we use AWS Spot instance to save costs?
Yes, I believe you can. I think that's what Epic does, maybe. I think there's references to that in the documentation, so I would have to look at that. But I think then you would need to worry about hydrating those workspaces as well.
I think one more question, then Ash, I'll drag him to the dev lounge because he's very popular.
Oh, no.
Okay, thank you. Maybe it's for Devlon, but we are interested on the on-premise configuration. Simple question: can an agent enrollment be conditional? Something like the agent is down. Can we replace with other, or the agent is used by other purposes? So we exclude the agent.
So are you asking if when agents are down?
Yes.
Yeah, so it will look through the pools to find available agents. And if it can't find an agent, then it's just going to sit there and wait. I think there might be a timeout as well. Yeah. Sorry, does that answer your question?
Maybe we can continue.
Yeah, that's good. Cool. I think that's it then. Thanks for listening.